Okay, thank you. Okay, now we will move to chapter 7. Before we talk about chapter 7, I just need to review some idea of the relation. Okay, previously, once we talk about function, for example, A and B. So once we have a function, we put like this one, we put F. For example, 1, 2, 3, here A, B, C. So once we have, especially function 1 to 1, so 1 map to A, 2 map to B, 3 map to C. Then after that, we talk about A map to A itself, A. So we have 1, 2, 3. So 1 map to 1, for example, 2 map to 2, 3 map to 3. Okay. This function, it call itself, where we call bijection. Once we talk about bijection, where the set map to itself, so we talk about permutation function. Okay, after that, when we have, for example, A, element 1, 2, 3, but once we talk about here, from means from and to. In general idea, once we have one set, for example, we represent by A, maybe we represent by B, maybe represent by C, and so on. This set A, B, C, either we utilize A or B or C, we can group it as one group of set. The group of set we call as input. It means this set we have input from here to here. Means once we have two there's two situation from and receive from here to here. So this one, this is the input. This is the input. This one is a output. Input and output. In the middle of input, in order to get output, we have another one part we call process. So once we have input, we give input to the process. This process, we do something here and give the output. So this process actually we can represent as a function. Once we have input here, previously in human understanding, we can utilize either 1, 2, 3, and so on. Based on this situation, so we process 1, 2, 3, we can get here A, B, C. Here from 2. 2 means output. So in the middle, we do some process where this process we call function. Function of what? Of input. This input we represent by X. Actually, this X can be 1, 2, 3. And function of X, then we can get output. So this actually will be Fy. So based on the processing of X, so this function process and we get Y. So we get Y, sorry, not function of Y, we get Y. So that's why in any in a general idea in maths, we say Y equal to Fx. See, we do something on X and we can get X. So do something represented by function. So actually this function is process. Once we talk about input-output process, actually we talk about computer. So computer actually, once we talk about computer, computer consists of input, output, and process. So whatever thing we have input, output, and process, we call computer. Okay. From discrete perspective, input actually is represented by sum of the set. I mean here. It may be set of A, B, C, and so on, like this one. Maybe one set. So, from computer perspective, 1, 2, 3 is input. Maybe also output we can represent by 0 and 0 or 1. So when let's say this one is this I, we take up from A. So 1, 2, 3, maybe we can represent by 0, 1, 0. So 0 mapped to 0, 1 can be mapped to 1, 0 can map to 0. So based on this general idea, we can say that I actually is a set of input, set of input. So set of input, it means maybe A, B, C, and so on. So in each offset, we can say this 0, 1, 0, we can represent by S. Set S state. So what is the total of 0, 1, 0 can represent Sn. So it may be 0 or 1. So here there are three input 0, 1, 0 actually represented by 0 and 1. So we put as one set. So we have input, we have data in input. So based on this idea, it may be can represent as this one. So the output, once we generalize, also can represent by this one. So we can say that if we have Sn, it may be represented by S0 because 0 and 1 or S1. S actually stand for state. In Malay we call keadaan. Okay, state 0 or state 1. So it represented by Sn. So this concept actually we generalize from this idea and this idea. So now we have I and S or Sn. So represent by this one as input represent means the set of input. Then each of the set we have the element. This element represent by S0, S1. Actually is 0 and 1. Okay. Another thing is F. This process we represent by function. So F0 or F1. So if we process here the input 0, it will be F0. And maybe here change to F1. Input 0, the output 1. But it determined based on function. So now we have input, state, and function. This idea we generalize based on the relation in set. Okay, that's the what we call the simple idea before we talk about function state of finite state machine, or we call FSM. Okay. Now, once we know what is R, what is S, what is F, we go to the definition of state finite machine FSM. A machine is a system. Once we talk about machine, any machine. In general, machine we talk about system. System is a complete cycle that we can accept an input. So we have input, we produce output, and we have internal memory when we can keep track all the information based on the previous input. So this is the definition of machine. So machine, once we talk about machine, actually we have input, we have output, and we have one set of we call memory. Once we process input output, when we have this process represented by a function process, we need to have memory. Sometimes we utilize internal memory, sometimes we utilize external memory. The important thing is we have input, process, output, and memory. So all these things actually is a machine. When we have this component, then we can call machine. Okay. So finite state machine, we talk about state finite in the machine state finite machine where, for example, we have S0, state of 0. We give the input and we process inside, then the output will S1. So if we give S1 for the process, the output will be S0. So we can see they have 4 conditions: S0, S1, S1, S0. It may be S0 and the output is S0. It may be we give S1, the output will be S1. So the output will be 4 conditions. 1, 2, 3, 4. Actually, these 4, once we summarize it, this also SO, this SO, this also S1, this S1. So once we summarize, it will be S0 or S1. Here also, we have S0, S0, S1, S1. So represented by S0 and S1. So once we talk about S0, S1, give the process and the output may be S0, S1. So this process actually represented by function. Can represent by function. So we summarize this idea, it will be, if we have here S0, S0 and F0, the output may be S0. S0, F1, F0, F1, the output will be S1. S1, F0, F0, the output will be S0. S0, F0, F1, S0, S1, S1, F0, the output will be S1. So all this combination we can generalize as triple SIF, we call finite state machine. As I said previously, S may be represent S0, S1, and so on until Sn. So set I is a set of set A, set B, and so on. So represented by set I. So function actually from S to S. So this function we can represent as fx. So once we have S, the first component, as I as the second component, third fx represented by f. So these 3 components, once we have triple set of SIF, that's why we call finite state machine. So in other words, we talk about state, where the state set of the machine and the element as we call states. So to understand finite state machine, quite tricky because it based on the formulation. But in order to solve the problem based on the application, is easy. I will show to you. Now, as I said previously, fx is I. So the formula based on function s times I. So we can represent f0 s0 s0, f0 s1 s1, f1 s0 f1, s1 f1 f0. So we can represent by this equation. Okay. So we have one input, there are 2 output. Why one input, 2 output? Because of because of 2 of n. We have, if we have 2 input, n of output. If we have 2 n here, n equal to 2, the output will be 4. If we make n equal to 1, input for 1, the output will be 2. This formula, please remember this formula. 2 power of n. Okay, this one is not important. The important thing is this one. If here is column represented by process F, it means process. Here row 1, row 2 represented by input. In the middle, inside the matrix actually is output. So please remember the section. Column represented by process F, input represented by S0, S1. In the middle, inside the matrix, actually is the output. So input, process, output. So if we put here, based on here, input with the process, we can get output. So we can normalize it S0, here S0, and F0 times with F0, it will be S0. S0 with F1 will be S1. S0 times with F1 equal to S1 and so on. So you must remember this table. Okay. This table we do not call matrix, we call STT, state transition table. Okay, now second example. This second example related to your assess or your assignment. Okay. Please consider that the STT state transition table with this function. Based on this function, try to produce the combination here. So we can see here S0, AA, B, S0, S1, S2. So based on this transition table, we can get the process where S0, FA will be S0 here. S0, FA will be S0. S0, FB, the answer will be S1. So S0, FB, the answer will be S1. Now we have S1, FA, the answer will be S2. So S1, 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 FA, the answer will be S2, and so on. Okay, this table we can transform to diagram. So how we transform the diagram? We know this one is function, this one is input, this one is output. So the important thing is input map to output. What is the process? So now we draw S0 map S0. Now we have S0 1 point, S0 map to S0. What is the process? Okay, S0 map to S1, S0 map to S1. So S0 map to S1, the answer is B. Here, we put B. Then S1, we have S1 map to S2. S1 map to S2. S1 map to S2, the answer is A. S1 map to S0, that's B. S1 map to S0. S1 map to S0, B. Then S2 map to S1, S2 map to S1, A. S2 is S1. S2 map to S2, S2 map to S2. The answer is B. This is a diagram to represent this is transition table. Class, okay tak? This one is very important. Given to you a trusted transition table, then please use the diagram. So from here, transform to here. Okay, kejap ni. So this answer, once we put in proper way, we will look like this one. So this one is based on the example 2. Actually, it is the same. Yeah. Again. Example, next example, actually this one is example 3. So example 3. Give you, this is function, this is process function, this one is input, in the middle of the state transition table is output. Now, given to you is this table. How you draw the diagram? So draw the diagram for this issue. So this is the answer. Okay, see? In order to draw like this final answer, we will look on step here. 0 map to 0. So S0 map to 0 A. Okay, settle. Here and here. Now S0 map to 0 S0. So it is the same idea. S0 map to S0. Actually is A, B. Same thing. We can draw another arrow. But actually it is the same arrow. So A, B. S0 map S0. It's the same idea. C. So A, B, C. Okay, finish this row. Then second row. S1 map S2. Put here S1 map to S2. S1 map to S2. The process is A. So we put A. Finish. S1 map S3. So S1 map to S1 map S3. S1 map to S3. S1 answer is B. Finish. Here B. S1 map to S2. S1 map to S2. Repeat process. S1 map to S2. So A, C. Now finish second row. Third row. S2. We focus on S2. S2 map to S1. A. S2 map to S2 map S1. A. S2 map to S0. S2 map to S0. B. Finish. S2 map to S3. S2 map to S3. C. Then finish. The third row. Now for S3. S3 focus on S3. S3 map to S3. S3 map to S3. So the answer is A. S3 map to S2. S3 map to S2. S3 map to S2. The answer is B. S3 map to S3. The same idea. Yeah. S3 map to S3. C. So just comma C. So this is the final answer. Once this state transition table compute a diagram. So this is the answer. Okay. So for class Asri. Asri okay tak? Okay. The others? Okay tak? Azad, are you okay? Good. Mahidi? Okay, bagus Zafran. Asal yes, good. Okay, now we move to exercise. Okay. Given to you this exercise. We have S0, S1, S2, and 0, 1. So please draw the diagram. So how to draw the diagram? We have S0, S1, S2. Now S0 map to S0. So S0 map to S0. The answer is 0. S0 map to S1. S0 map to S1. 1. Finish. Second row. S1 to S1. S1 map to S1. The answer will be 0. Finish. S1 map to S2. S1 map to S2. The answer is 1. Finish. So second row finish. Now we focus on S2. S2 map to S2. S2 map to S2. The answer is 0. S2 map to S0. The answer is 1. This is the answer for this exercise. Okay. Is easy? Good. Zazak. 100%. Good. I'm happy. Now the second exercise. We have 3 functions with 4 input. For input S0 until S4, S3. 3 process ABC. Okay, now we have S0, S1, S2, S3. So actually, I draw the first step. How many inputs? So I draw S1, S0, S1, S2, S3. Now S0 map to S0. So S0 map to S0, A. S0 map to S1. S0 map to S1, B. So S0 map to S2. S0 map to S2. The answer is C. So finish first row. Second row, we focus on S1. S1 map to S2. S1 map to S2. So finish A. S1 map to S1. S1 map to S1. The answer will be B. Finish. S1 map to also S1. So just normal CC. Finish second row. The third row, S2 map to S1. So now focus on S2. S2 map to S1. A. S2 also map to S1. B. So we just confirm. S2 map to S2. C. S2 map to S2. C. And then finish. Now we focus on input S3. So S3 map to S2. S3 map to S2.
Ada silap tu.
Mana?
Yang S2 map to S1 tu.
S2 map to S2 map to S1. So sorry. Saya tengok ini S0. Sorry. Thank you. Yang ni. Betul. Okay. Sorry. S2 map to S1. I thought it's S1. So A and B. Okay, thank you. Okay. S2 map to S1 provides A and B. And now S3 map to S2. A. S3 map to S0. See, do not cross this mapping. We need to add S3 map to S0. Like this one. If you cross, it will be wrong because in engineering, this one cannot be crossed. It will be a short circuit. So you must put like this one. So S3 map to S0, the answer is B. So S3 map to S1. S3 map to S1. Answer is C. So this is the final answer for exercise 2. Okay, class. Okay, class. Is it easy to understand? Good. Bagus. Saya jawab ni. Betul saya ni. Okay, bagus. How about the others? Zafran, ini, okay, good ini. Chom, good. Okay, bagus. Zinirah, okay, Zinirah. Okay, orang Zafran, okay, bagus. Okay, bagus. So I hope for exercise 3 and exercise 4, please do it for yourself. If you can answer these two exercises, exercise 3 and exercise 4, I think there should be no problem once come your test and then or your assignment. Okay, class. Try and please answer for exercise 3 and exercise 4. Okay, class. So far, any question for 7.1? Any question? And let's take question. Okay, how about the others? Asli, okay, good. Zahra, good. Sasan, Mahdi, did you get the idea? You get the picture what is 7.1? Picture, good, okay, good. Zaza, okay, Mahdi. Zaza, okay, good, nice. Okay, so that's it for 7.1. So I stop here. I stop for now. So we continue for 7.2 and 7.3 in the next class. So that's it for today. I hope you do your exercise 3 and exercise 4. Okay, class. Okay, if there are no questions, I think we can stop here. Thank you very much. Bye-bye.
Okay, go.
Okay, welcome. Okay, then sekejap. Okay, welcome. Please do your exercise.
Bisa.
Good.